Hello Algebra 2 students, this is Mrs. Uteg for room 338. Before this video starts, I always say this, grab a healthy snack because your chewing will not bother me. Tonight is mental math night, so you cannot use a calculator. I don't want to see you pulling those things out. This is a challenge for all of you mathletes. You have a December meet coming up, so I'm hoping that this probability challenge that I made will be useful for you guys. So without any further ado, I'm going to go ahead and read it. Mrs. Uteg, that's me, is playing a game where she will pick a positive integer less than or equal to x. Then she will roll a fair x-sided die x times. What is the probability that the integer that she selected, that's me, earlier is rolled at least once as x approaches infinity? Alright, so let's make some sense out of this problem. So x is just a variable here, and we're saying that x is going to approach infinity. So let's just assume for right now that x equals 6 so that we can, really find out what this problem means. So basically if x was 6, then I would pick a positive integer less than or equal to 6. So that would be 1, 2, 3, 4, 5, or 6. Let's just say that I pick 2. Or actually no, 4. 4 is my favorite number. Then she will roll a fair x-sided die x times. So since I already said that x is going to be 6, I'm going to roll a fair 6-sided die, which is what we usually use, and I'm going to roll that 6 times. So what is the probability that the integer that I selected earlier, I selected 4, that's my favorite integer, is rolled at least once as x approaches infinity? Well, this x approaches infinity, of course, that's not going to be where we chose 6. So basically, instead of choosing 6, I'm going to say, let's say that x is infinity, or is approaching infinity. So what is that probability going to approach? What constant? So I'll give you guys some hints since this is going to be hard. Remember your formula here for binomial probability. This is that the event will occur. It is n factorial over r factorial times n minus r factorial times p to the r times 1 minus p to the power of n minus r. I don't know how you guys first learned this. You might have learned that it's q to the n minus r. I don't really want you guys to do that because, well, q is just 1 minus p and it just adds difficulty. So of course n is the total number of trials, so n is going to be, well, I'm not going to tell you what it is. R is the number that we wish to obtain. I'm sorry, Algebra 2 students. Of course, since we're rolling it, we want it to roll at least once, so I don't know how you're going to decide to do this, but keep that in mind. And p is the probability that the event will happen. So here's your second hint. Try to find the probability that Mrs. Uteg, that I'll lose first, that it won't be rolled at least once. That will just make it easier. So I want you to go ahead and give a swing at that. And pause the video and we'll be right back. Alright, so I'm assuming that you attempted the problem. So let's go ahead and let's try to do it together now. For n, we're going to want to choose, and I'm going to first find the probability that I'll lose, because when you think about it, it's easier to just find r equals 0 for when I lost than to find r equals 1, then 2, then 3, then 4, because if we look back, it says that I get, it rolls up more than once, so that could be any integer up to infinity, and including, well, the limit of infinity, let's just say. So n is going to be infinity because we're rolling it x times, and x is approaching infinity. As I just said, r is going to be 0, and p is going to be 1 over infinity, because, if you had a die that was 12-sided, if it said it was fair, the probability of a certain integer popping up would be 1 in 12, so now it's just going to be 1 in infinity. So let's substitute these values in. As I just did, we're going to get infinity factorial over 0 factorial times infinity minus 0 factorial times 1 over infinity to the 0 times 1 minus 1 over infinity to the infinity minus 0. Now, I want you to keep in mind, mathletes, that 0 factorial is equal to 1. If you want a proof of this, I guess I'll show you during class. I guess I do that. So yeah, let's put this in. And also, remember any non-zero real value, let's say, to the 0th is 1. 1 over infinity, that's the limit, so we're not going to say that's 0. Well, we're going to say that it approaches 0, but we're going to say that it's 1, just for argument's sake. So we get this. As I said, 0 factorial is equal to 1. So of course right here, we'd be getting 1 times, well, this is just going to go down in these parentheses, 0 factorial. So then this is going to become infinity factorial over infinity factorial, which is 1. So we're left with this business here. So we want to find this limit. This looks a lot familiar to my Algebra 2 students, because as x approaches infinity, we know that 1 plus, this is minus, but 1 plus 1 over x to the x equals e. You could just put in infinity pretty much where these x's are. So my question is, what is this? Maybe you haven't seen it written this way, limit as x approaches infinity, but that's similar to when we did, remember when we did end behavior? Well, I hope you do. This is just the same as x approaches infinity of this, and this would like be your f of x, I guess. And this would be what f of x approaches. So I'm just going to tell you that this is all equal to 1 over e, or e to the power of minus 1, however you want to write that. So what I want you to do right now is I want you to prove that the limit as x approaches infinity of 1 minus 1 over x to the x is equal to e to the power of minus 1, which of course is equal to 1 over e. So go ahead and pause this video and give it a try. Alright, I'm assuming that you've attempted it. So now I'm going to slowly prove this. First, I'm going to assume for this to be true. And we'll see if we get any contradictions. If we do, then it's not true. If we don't, then it is true. So think of this as e. All of this is the limit as x approaches infinity. This is e, and we're saying that that's equal to 1 over 1 over e, which of course that would be saying that e equals e if this is true. So let's move on here. I'm just going to cross multiply. Okay, and then I'm going to, this is kind of like a dots. Don't say dots. This is a difference of 2 perfect squares. And we're just going to do this backwards. So if you were to factor this, you would get 1 minus 1 over x squared. Another note is that these are both to the x, so this is going to be to the x. That's just a basic, that's just a basic polynomial property. Let's take the xth root of 1. Now we said that x approaches infinity, and as we know, any positive root of 1 is equal to 1. So like the square root of 1 is 1, the 2016th root of 1 is 1. So I can do this. I'll subtract 1 from both sides. This would be 1 minus 1, which is 0. And I'll square root both sides. Square root of 0 is 0. The square root of this, well, this is just the square root of 1 over the square root of x squared. So then we're going to get 0 equals 1 over x. And just to remind you, the limit as x approaches infinity is what x is. So we have our answer. This does work. Mrs. Uteg is happy. So we're going to tie this all together now. Sorry, this video is getting a little bit long. I don't want to keep you up all night, but this will be the last part for tonight. I want you to look back at the original question and answer all parts of it. Alright, so now we just found that the probability of myself not winning is e to the minus 1. So what is the probability of myself winning? Well, obviously if I don't not win, then I win, right? So if we take 1 minus this, that's going to be our answer. The probability of me winning, of course, is if I were to, the integer that I selected earlier, whatever that might be, comes up at least once. So basically we're saying 1 minus the probability of the integer not coming up would be the probability of the integer coming up. Okay, so written it's just 1 minus e to the minus 1, which of course that's 1 minus 1 over e. That's the probability. And that does, well, let's type that into our calculator here. You don't have your calculator out. You're not supposed to. But I will break the rules a little bit here. If you were curious, that is approximately equal to 0.632, the chance of me winning as x approaches infinity. So I have a little bit of a challenge question for you. You can tell me the answer tomorrow. We know that this is the answer to x as it approaches infinity, but what if x was less than x approaching infinity? Meaning, what if x was like 2016? As x gets larger, does the probability of myself winning increase or decrease? Obviously, it's not going to stay the same. So if you have any questions or the answer to that question I just proposed, see me in next class. This is your only homework tonight except for that challenge, and have a great night.